In this video, we will learn how to deal with a continuous variable in statistics. We will learn how to group the data in intervals and how to find the most important parameters, central and dispersion measurements. This is our collection of data. These data represent the weight in kilograms of 50 students. We are going to group them in intervals as follows. We have set up 7 intervals. The first one from 19 kilos to 35 kilos. The next one from 35 to 50. Next from 50 to 65, 65 to 80, 80 to 95, 95 to 110, and 110 to 125. The bracket on the left side means that the number is included, and the parenthesis on the right side means that that number is not included. In the first place, we are going to find the midpoints of each interval. The midpoint is the number in the middle, so we add both edges and divide by 2. So the midpoint of 1935 is 19 plus 35 divided by 2, which is 27. In a similar way, we do the midpoint of the other intervals. For instance, the midpoint of the next interval, 35 to 50, would be 35 plus 50 divided by 2. So that's 42.5. So these are our midpoints for all the intervals. So now we are going to count how many values can we find between 19 and 35. You can stop the video here if you want to do the counting yourself. Then we will count how many data we have between 35 and 50, which is our next interval, and so on until we get the frequencies for all of the intervals. And these are the frequencies for each of the intervals. Remember that we have included for each interval the first number but not the last. That is, for the first interval we have included 19 but not 35. In the second we have included 35 but not 50. And the third we have included 50 but not 65, and so on. And now we are going to multiply the midpoints times the frequency. So the xi times the fi. That way we will create a new column called fi times xi. So we multiply 27 times 4, 108, 47.5 times 8, 340, 57.5 times 18, 1035, and so on and so forth. And then we add them up, add all the numbers we have obtained, and we obtain the sum of fi times xi. And now we are going to create a new column by multiplying the midpoints by the last column. So we will call this new column fi times xi squared. So we multiply 27 times 108, that would be 2916, 42.5 times 340, that would be 40,450, and so on. And at the end we will add up all these numbers and we will obtain the sum of fi times xi squared, that is, as we can see here, 240,203.5. And now our frequency table is complete and we can start calculating the parameters. We start with the central parameters, the mean, which is simply the sum of fi times xi divided by n, that is 32.63 divided by 50, which is 65.3 kilograms. Now we are going to find the median interval. The median interval is the interval containing the median data. As we have 50 data, if we put them in order from the lowest to the highest, the median data would be the 25th and the 26th data. So we can count the frequencies, and we can see that the 25th and the 26th data are in this interval, an interval from 50 to 65. So now we find the modal interval. That's easy because it's just the interval with the highest frequency. So it's the same as the median interval. It's the interval from 50 to 65. And finally, we're going to find the dispersion parameters, the variance, which follows this formula, the sum of fi times xi squared divided by n, minus the square of the mean. So, replacing the numbers in the formula, we obtain 539.98. From the variance, we obtain the standard deviation, which is simply the square root. So 23.2 kilos, because it has the same units as the mean. And from the standard deviation and the mean, by dividing, we obtain the coefficient of variation, which in this case is 0.355, so that's approximately 35.5%.